Hey everybody, I'm Andrew from the Flutter team, and welcome to our null safety workshop here at IO21. Thank you for joining me. We're going to go through some null safety stuff, starting with beginner, some basic principles, and then advancing to some more interesting patterns along the way. And we're going to be doing it in Dartpad. So this is Dartpad right here. This is our online code editor and playground for Dart and Flutter code. We're going to be using it for Dart today. But if you haven't already, I'd love for you to find this workshop on Dartpad and follow along with me wherever you are. I'm sitting in front of a text editor here, so I'm actually just going to show you the URL here. We set up a redirect link on flutter.dev. There we go, and it's bravely trying to autocomplete that. Thank you, Dartpad. If you hit that link, you're going to end up on this page on Dartpad with the same exercises that I'm about to walk through. So I'll leave that up there for just a second, and I'll explain what we're doing here. If you haven't seen Dartpad, by the way, it is our online playground and editor, like I said, for Dart and Flutter code. In this case, we have some instructions for this workshop on the left. You can kind of ignore those if you're watching this video, this stream, because I'll be explaining what we're doing as we go. But if you come to this same workshop later and you're just looking at Dartpad, those will be useful for you. We have a keyboard icon down here that I could open up. So we have some shortcuts there for the editor to do things like run code. You can do Command Enter or Control Enter, and format is Shift Control F there for formatting code. And one other thing you'll want to know, actually two other things you'll want to know about, that we have a stepper here for the steps in this workshop. There are 13 steps we're going to go through, and there's a run button up here. So when you're ready to run some code, that's what you do. And last but not least, down here, there's showing and hiding. So if you have an analyzer error in the code, you see some red squiggles up here, you can hit show and hide to see those down here. Right now, Dart's complaining, for example, that I put a string literal just randomly in a file where no string literal should be. So let me go ahead and take that out. That's that URL. Hopefully you're joining me. One other thing, these exercises are a little unique. A lot of workshops, they start off with something simple and they sort of build on it until you get to an impressive conclusion. This is a little bit different. The 13 steps are all independent from each other, and most of them start off broken. So if you're watching this workshop, this is sort of my way of having some fun and getting people to go through fixing my broken code. And along the way, we'll learn the basics of null safety and some more advanced things that it allows us to do toward the end. And with that said, I guess let's dive in. So Dart null safety, also known as non-nullable types by default. You might have seen NNBD as an acronym thrown around a little bit. You might have asked, what is a non-nullable type, right? It used to be that before null safety, any type in Dart could be a value, a valid value or reference, or it could be null. If you declared an integer, for example, like I've done here on line 2, I just got integer A. That could have held either an integer value, -1, 13, or 0, or it could hold null. Now, though, with non-nullable types by default, once you opt in to null safety, that becomes a non-nullable type. That's the by default part. And so this can no longer, on line 2, that integer can no longer hold a null value. It has to have an integer value. And so you can see on line 3, I'm still assigning null to it. I'm still telling Dart, hey, I want a non-nullable integer, and I'm going to stick null in it. And Dart puts up the red line there, and it gives me an analyzer warning. It says, hey, that's dumb. I'm not going to do that. And Dart's null safety system is sound, by the way. And what that means is that Dart will protect you from ever getting into a situation where a variable that you've declared as non-nullable ever has a null value in it. It can guarantee at any given moment while an app or a program is running that no non-nullable references point to null. And that's what they mean if you see that word sound on some of the documentation, that's what it means. So let's take a look here. In this case, this is a fairly easy one to fix, right? I've got integer, I'm declaring an integer of a variable A of a non-nullable type. And then on line 3, I'm assigning null to it. So one way I can fix this is just to replace null on line 3 with a number like 3. You can see my analyzer error just disappeared because I'm no longer violating null safety. I can click the run button to run this code, and there it is. And so a lot of these, as you'll see, are going to start off with those little red arrows that say, hey, there's a way that a null value could get into this code, and Dart will ask you to fix it. Often it does that by asking you to make decisions about what would happen if a null came in there. You'll see that come up later. All right, but that's a non-nullable type. On to step 2. All right, so this code looks remarkably familiar. So you might be wondering, if there are now non-nullable types, what happens if I do want a nullable type just like I used to have, right? What if I want a value that could be an integer but could also be null, or could be a string but could also be null? Maybe deserializing some data, you have optional fields, and you get those, and you want them to come back as null for a little while so you can properly represent no value. You can still do that, and you do that by modifying the type declaration with a question mark. So here again on line 2, I'm declaring that integer. I can come in here and put a question mark there. And that tells Dart, hey, I would like for that to be a nullable integer. So it can contain not only one of the many integer values, but it can also contain null. So now Dart's totally cool with me assigning null to it because it's a nullable variable now, which means I can come up here, hit the run button, and it'll print out that A is null. So there you go. We now have non-nullable types, and we have nullable types, which you can see with that question mark. All right. Let's check out something slightly more complicated. This is step 3, nullable types with generics and type parameters. So can I move this any? No. All right, so in this exercise, I've got 3 fields, the 3 variables that I've declared. I've got 3, and they're all lists that you can see. Use string for their generic type parameter that goes into the list, because you have a list of strings, list of integers, whatnot. You could also have a list of nullable strings or nullable integers. And so you can already see that Dart is a little concerned here about this one and this one. So first on line 2, I've got a list of strings, and I'm giving it a list literal, right? So you can see the brackets here that define a list literal for Dart. And then I'm giving it 3 strings, 1, 2, and 3. And so that is a proper non-nullable list of non-nullable strings, right? I'm definitely assigning it a list, and the list has nothing in it that's null. So I'm great there. Now here I've got a nullable list of strings, and I'm not assigning a value to it, which means it would normally initialize to null. But I've still declared it, and you can see here at the beginning of line 3, as a list of string. There's no nullability in there. There's no question marks. So Dart's going to be worried about that. I'm saying this is non-nullable, but I'm not initializing it, and that's a problem. Then down here, I've got a list of nullable strings, which has null as one of the 3 values that's in it. So the list is there. The list isn't null, but one of the values in it is, right? And you can see I've got an analyzer warning about that as well. So here's a question. We just looked at how to use a question mark to declare a type that's non-nullable to be nullable, right? We took int, we put a question mark on it. Take a second and look at lines 3 and 4 and see if you could figure out in Dartpad, wherever you are, see if you can figure out where to add the question mark to make those analyzer warnings go away. I'll give you a little time here. See if you can figure it out. All right. The wonderful thing about Dartpad being a playground is that undo works perfectly well. Some of y'all may never have used a non-nullable type with a generic parameter. Here, I've got a nullable list of strings. And so the place to add that question mark is right there. So that whole type declaration, list string, that is a type in and of itself. And I want to say that list, that whole type can be nullable as well. So it could be a list or it could be null. So I add the question mark all the way at the end. Here, I've got a list, and I want it to be a list of nullable strings. So I go in right here, and I put my question mark there. So it makes the string type into a nullable string. And now I can assign a null value into that list. And I believe if I hit run, there we go. So I got compilable null-safe code. All right. Let's take a look at step 4. Got some analyzer errors here as well. Okay, so what happens if you have one of these nullable fields, right? You have a value coming in, and it might be null, but you want to take it and turn it into a non-nullable, store it in a non-nullable reference with a non-nullable type. Let's say you have a value coming in, and you're calling a function, and you know it could return a null, but you know it's not going to. And so you want to tell Dart, hey, just trust me. This is a nullable value that's coming out as far as the type, but I know it's not going to be null, so I'd like you to treat it as if it's a non-nullable value. You can use the null assertion operator, which is the exclamation mark. And so you can put that after an expression, and that will tell Dart, treat this, convert this to a non-nullable reference, and just trust me that it's not a null value. If it is a null value, by the way, you would get an exception at that point. So make sure that you know the responsibility you're taking on when you do that. And all right, let's take a look at our exercise here. So we're declaring some things, lines 1, 4, and 5 here, I think, are the important ones. So up here on line 1, we have a function called could return null, but doesn't, that always returns -3. That's what it always evaluates to. But you can see at the beginning of the line, it's declared as a nullable int return type. Right? So it's never going to actually return null, but it is declared with a nullable integer return type. Here, on line 4, we've got could be null but isn't, which is a type variable that's assigned to 1 is the value that's going into it, but it's also got that integer question mark on it. And on line 5, we have a list of nullable integers called a list that could hold nulls. It has a null in it right here in the middle. And so if you were to query a particular index in that list, first or last or something like that, in theory, you might end up with a null. And so you can see down here on lines 7 through 9, we're using some of those values and assigning them to non-nullable fields, right? I've got int a equals int b. So those are non-nullable integers. They cannot accept a null. And so Dart will tell you, if you try to stick a nullable value in there, hey, you got to do something here. You got to tell me what to do, because I can't handle a null there. So in this first one, this is an interesting little bit here. Dart is smart enough to see that this is a literal, and because it's in the same function scope, it will actually treat it as if it were a non-nullable field. Dart's static analysis is smart enough to say, hey, that's in the same scope. I know nobody else could be messing with that variable, and so I'm actually going to treat it as if it were non-nullable because I know it's a 1. We're going to talk a little bit more about that process in a second. It's called type promotion. For right now, watch what happens, though, if I take it out of that scope and I put it up here. Full scope. Now Dart's not so sure. It's not inside the same function anymore. It doesn't know maybe something somewhere else could be messing with that value. So it's like, hey, that could be null. And what I do is I come in and I put that exclamation point on it. And I tell, hey, Dart, you trust me. I know what I'm doing. Just please take this value and put it in that non-nullable reference. I promise you it's not null. Now, if I'm wrong, it's going to throw an exception. But in this case, I, the programmer, know that it's not going to. All right. So let's take a second. See if you can get those other 2 analyzer errors to go away using that exclamation point. Remember, you put the exclamation point at the end of the expression that could be null, but you know for a fact isn't. I'll give you a little time to try that out. Next time we do one of these workshops, I'm definitely bringing theme music with me to play during these moments. All right, let's see. So here, it's the list that could hold nulls. You might have first tried to put that exclamation point here, right? Because that seems like it might be the right place. But the list is not null, and it's never ever going to be null. We declared it as a non-nullable list of nullable integers. So it's those integers that could be null. And the integers come out here with first. That's the property that could be null. And so that's where I put my exclamation point at the end of that full expression. If the list could have been null, then I would have put it at the end of the list. All right, down here, we have could return null but doesn't. It's that function. It's not going to return null, but it has a return type of a nullable integer. And so again, I put my exclamation point at the end of the expression. And that's how I tell Dart, this expression, it's got a nullable type, but trust me, I know what I'm doing. And so I can run my code now, and it works. All right, so that's the null assertion operator. Again, it's that exclamation point you put at the end of an expression to tell Dart just to trust you. You know what you're doing. All right, the required keyword, and we have 3 more analyzer errors to deal with. So show of hands, who out there has seen, and I know I can't see you, but show of hands anyway, who of you out there has used the required annotation before? How many of y'all are familiar with that? There's some other annotations in Dart. Override, for example, is one that I still use. Before the advent of null-safety, there was an annotation. It was just a little @ symbol and then required that you could put on optional named parameters to say, hey, this isn't actually optional. I need you to give me a value with it. And that was something that was used to force people. You could declare a function and force people that were calling the function to pass the parameters that you knew you needed, even though they were technically optional. And that used to be enforced by a linter. It wasn't actually enforced by Dart static analysis. For null-safety, that has changed. And there's now a new keyword called required. It's one of 4 new syntax elements, all of which we're going to cover, that they've added. And it can be used for the same purpose to say, hey, if you're going to call this function, this optional named parameter is actually a required named parameter. And you need to, you cannot call this function without including it. And so I can come up here and I've got this function starting on line 1, add 3 values. So it takes in 3 integers, it adds them up and returns the sum. And so you can't add something that's null, right? So I'm going to take in those numbers using non-nullable types. I've got integer, integer, integer. So I can guarantee that I can do that math. And that means that I have to have values. I can't leave those null if somebody doesn't include them. And so that's why Dart is concerned. It's like, hey, what happens if somebody doesn't include first when they call this function, right? I'm going to have a problem. So I come in here with required, just like that. And that'll take care of the first one. Take care of the second one. And that'll take care of the third one. So now my analyzer errors go away. I can run this code. And I come up with a sum of 10. I'm calling that function right here on lines 10 through 14, providing all those parameters. And now watch this. What happens if I take this out? Right? If I don't supply that required parameter, Dart knows that's wrong. Before I even compile my code, it knows that's wrong, that it's going to run into trouble. And so it flags it and says, hey, that's a compile time error. I'm not going to compile that code. So, and if I try to get tricky, you know, and supply it, but I give it a null, Dart will stop me from doing that as well. It says, hey, you gave me a value, but it's not a value that can fit into that parameter. It's not a proper argument for that parameter. Not going to compile. All right, let me switch this back to 2. While we're here, this isn't really in the instructions for this step, but just to make sure it gets stated. You could also solve this problem of needing a value by using a default value. That works as well. So here, I've not marked third required, but I've said, hey, if it's not included, just use 0. And then Dart can still initialize that parameter with an argument that is non-null and make sure that all 3 go into the function as non-null values. And so here I could, since I've given that third one a default value, I actually could comment this out. If I was like, I don't need the 3, forget that. I can still run this, and if math works out, it'll come out as 7. And there we go. So that's the required keyword. You can use it to turn an optional named parameter into a required named parameter so that you can use non-nullable types for those parameters and still take advantage of it. All right, that's step 5. Let's see, let's go on to number 6, type promotion. Okay. Let's, so this is about type promotion. We touched on that a little bit a little while ago. We were looking at that field that when I moved it outside the function, it suddenly Dart lost the ability to sort of understand that it wasn't null. That involves type promotion, where in certain cases, Dart can know by analyzing the code at compile time, not at runtime, at compile time. It can analyze the code and say, hey, that's a nullable field, but it's never going to be null. I can check all the branches, and I know that by the time I get to a certain line, there's going to be a valid value in it. And it can also do this with types. Let me just briefly comment some stuff out here, and let's talk about another type promotion example real quick. Say I had an object that I declared, and I'll say this is a string, like that. Right? Object is a very fundamental base class in Dart. I can assign a string to it, and I do have to give my variables names. There we go. Live coding for the win. So yeah, object A is assigned a string value. And so object is a base class, but I'm choosing to give it a string value. And so normally I would not be able to do something like print a dot length. Dart will stop me from doing that. It's like, hey, that's an object. That's what you declared it as. So you can't use a property that is present on a string. Even if it might be a string, that's not how you declared it type-wise. But if I come here and I check it first, and I say, if A is a string, it's like that. Here. Now Dart will let me do it, because it knows that by the time it gets to line 5 here, I've already checked that exact variable that's in the scope of this function. Nobody else can mess with it in the meanwhile while I'm looking at it. In the scope of the same function, I'm checking it to see if it's a particular type. And so Dart knows that if I get to line 5, it has to be a string. And so it'll let me print the length. And this should work if I hit run. And so I get a length of 16. So that's type promotion from a base class to a derived class. Let me take that back out, and we'll talk a little bit about how this works with null safety. So in this case, up on line 2, I'm declaring a nullable string called text. And then down around lines 10 and 11, I'm printing text, and then I'm trying to access the length property on text and printing that as well. And Dart is giving me the error. It's giving me the red underline because it knows that by the time I get down here, string could totally be null. There's nothing up here that says, hey, this is definitely not null. You don't need to worry about it. So it's like, hey, you, the programmer, need to worry about this on my behalf. There are a couple ways you could solve this. I could come in here and use conditional access. Use the question mark dot to access this. You may have seen this in Dart code already. It's been around for a while. This is a notation that says, hey, if text is not null, access the length property and then evaluate this expression to that. If text is null, don't try to access the property because it's not there, and just return null instead. And that's a way to guard calls to methods and properties. There's another way I can do this, though. Check this out. I'm going to uncomment this code. We'll take a look at it. This is an if-then statement that's just checking the hour of the day. And then if it's morning time, it says, hey, it's morning. Let's go make a lou paratha, which is a lovely breakfast dish. And if it's not morning time, it says it's afternoon. Let's go make biryani. Also a delicious dish, but takes a while to cook. So afternoon. And Dart looks at this. You'll notice that red underline has gone away. Dart can look at this and say, okay, that's going to branch. I declare the variable. There at line 4, I'm going to branch. And I have 2 branches. In both of those branches, a value is getting assigned to text that isn't null. And then after that, I'm coming back together and I'm going down to lines 10 and 11. And it's able to say, hey, by the time I get to line 11, I can know for a fact that text will have a value in it that's not null. And so Dart will automatically promote that type to be treated as a non-nullable field, as a non-nullable variable. And so I no longer have that risk there, and I can print this. And yeah, it's morning. It's 1 a.m. here on the west coast of the US, so a lou paratha time. Maybe it's biryani hour where you are. And so that's type promotion with nullable fields and how they can be treated as non-nullable. It's a way for Dart to save you some syntax. All right. Let's look at some other ways to do it. So here I have a function called getLength that accepts a nullable string, right? And it's going to return the length of that string. And so I'm getting that complaint. Dart's like, hey, nullable, can't do that. You gotta help me out here, right? And then in main, you can see here, I'm just printing the result of getLength and I'm passing it a string literal, right? But up here, different scope inside this function and Dart's concern. One of the other ways that you can do a type promotion is with a null check. So I could add, and actually, why don't y'all try this? Do a little check and say, if string is null, return something else. You know, you could decide, how would you handle null here? Get length of a string that's null, right? What would you return? -1 to indicate there was a problem, maybe? If you come from a C background, maybe that would be the thing to do. If you could return 0. And watch what happens to that underline on the length property once you have that, once you're returning something above if there's a null. I'll give you a second. All right, were you able to get it to go away? Let's see if I can do it. Let's come in here. say if string equals null, I'm going to return 0. Let's just put all aside here. And now you can see Dart's no longer concerned, because it knows by the time it gets to line 6, if string had been null, we would have returned already. So before we had two branches that both assigned a value, here we have one branch going off and saying, if it's null, go away. And Dart knows that it's never going to get back to line 6, unless that value isn't null. So that's another type promotion example. All right. Here's another one. Just like with the return statement, you can also use exceptions, because those also break you out of the flow of a function and can alter, basically give you a branch of the function that goes elsewhere. That can also do the same thing. So if I come up here and I say, you know what? If string is null, I'm going to throw an exception. And in Dart, you can throw any old object as an exception. So I can be like, hey, that string was in fact null. I can do that. And now Dart, again, has promoted that type for string, for str. It has promoted that to be non-nullable by the time we get to line 6, because it knows that if it was null, we would have popped out already. So now I can run this. And there we go. All right. Now, so that's several examples of type promotion, how it can save you a little bit of code by Dart being smart and knowing where things are likely to be null on your behalf. Let's look at an area. This is something that tripped me up the first time I looked at this, because we've been looking at local variables so far and type promotion. Let's look at an object property, an object field, right? So here, I've got a random string provider, and it has a value on it that is a randomly provided, right? So it's using random, and it's saying, hey, one time you call this, it could be one value, and another time it could be another. So it's going to return either a string or null. And I'm going to get an instance of that object here on line 11, and then I'm going to check it for null here on line 13. So I'm doing the same kind of thing, provider.value equals null, right? And then if it is null, I'm going to check. If it is null, I'm just going to print, hey, it's null. And if it's not, I'm going to try to print that value and access it a second time. And Dart's not letting me do that. And the reason it is reason it's not letting me do that is because accessing this property twice could produce a different value. And so this can be rectified by using a local variable to cache the result, to make sure that within the same scope that you're checking and using that value, you can cache it in a local variable, and Dart will know that it won't change in the course of the execution. So I could come down here and I could say, all right, rather than provider about that value just being on its own, let me make a little string here and I'll cache it. There we go. And then instead of checking this manually, I'll use that instead. And I'll use that instead. And now you can see Dart no longer has a problem with me using that value. I'm only accessing it once, and so I know for a fact that it won't change. Now let me look at, there's also another sort of reason. There's also another reason. It looks a little bit simpler when you start off, and it's actually step 10 here. I'm going to go back though, and I'm going to do it within this one. Let's build on this example since we're walking through this right now. Let's say I also had, let me comment out random string provider for right now. Let's make this super simple. And I'll say I have a class called provider, just like this. And it's going to have just a property in it. So I'll say string value equals, and I'll actually give it a very simple string like that. Then I'll come down here. I'll do this. And you'll see, even with this extremely simple example, Dart's still concerned about that second access of the property, which that seems a little bit weird too, right? He's like, hey, right up here, it's a literal value. I know I'm typing it as a nullable string, but it's a literal value. Dart why can't it know? Why can't it guarantee that that's the case? And it has to do with the fact that Dart does not have sealed classes. Some languages do have sealed classes. You can declare a class and say, hey, no one is allowed to extend this class. This is as far as this line in the inheritance tree goes. It doesn't go any further than that. Dart doesn't have that. And so let's imagine for a second that you're at a big, big company, or making a big application, or you have a lot of people working on the same app, right? So you probably wouldn't even have, you probably want to instantiate a string provider directly, right? You probably have like a string provider factory or something like that. Let's make one of those. String provider factory. And I'll give it a nice static method. Let's see, string provider. Get provider. I'll return a new string provider. There we go. And so let's say down here, say string provider factory. Nothing's changed yet. Let's say you come into work and you code this and you're like, hey, got a very simple string provider, no big deal, right? And then a few weeks later, somebody else in the company is working on something that sort of borders on what you're working on, right? And they're like, hey, that string provider is great. I'd love to extend that with a new feature of a random string. Have that be something we support. And in Dart, every property has an implied getter and setter, and those can also be overridden in extending classes. And so somebody comes along, they're like, hey, I'll make my own string provider that overrides that default value with a random one. How fun would that be? And then they update their string provider factory to output the random string provider. And now your code has not changed, but could still run into that randomness issue because somebody else extended your class and changed one line in a method and changing the type that was being used. Even though yours had that literal in there, it's still possible to extend that class. And so that's it's a really interesting way that the lack of sealed classes and the way that some of Dart's type inheritance stuff works can affect these sorts of things. So good news is this is easy to fix with a local variable as well. You can still come in here and say, hey, let's put this in a local variable, and I can come in here and use that variable without a problem. Just like that. So it's a little window into the way that type promotion works in Dart with object fields and with local variables, and some patterns that you can get help with. All right. All right, so I'm going to skip past, as you can see, I'm going to skip past step 10 here because we basically just did it in place. And let's take a look at another new piece of syntax. This is the late keyword. So the late keyword, sometimes, actually, let's start with the code here before going into the concept. So I've got this class, meal, right here on line 1. You can see me declaring it. And I've got a non-nullable string in there called description. And description is declared as non-nullable, but I'm not giving it a value. I'm not doing something like this to initialize it with a string, right? And the Dart's concerned, it's like, hey, that's not nullable. It's a non-nullable string. You're not assigning a value to it right away. When I initialize this object, I need to have a value because once that object's initialized, Dart has to put something in that field, and it doesn't have anything to put in there, right? So we also have on line 4 through 6 this set description field right there, this set description method, which will assign a value to that field, but that would be after the object's been initialized in a different time. And so Dart's concerns like, hey, I don't have a value right away, even though you're going to potentially call that method, and I am calling it down here in main. That's making Dart nervous. So what I can do is use the late keyword right here. This is kind of like that assertion operator. This is kind of like that exclamation point. It's a way to tell Dart, hey, I'm taking a little, the programmer, I'm taking a little responsibility here for this. I want you to trust me. I'm going to put a value in there before I read from it. And that's the kind of contract that I make with Dart here. I'm saying, hey, trust me on this. Description's going to start off, it's not going to have a value in it, but before I read from it, before I ever access that value, I'm going to stick one in there. So down here, of course, I've got, I'm making the meal object, right? Then I'm calling that set description method, and I'm putting in a description of feijoada, which is a wonderful stew. If there are any Brazilians watching right now, thank you for inventing it. And then I'm going to try to print that description, right? So I can run this code now, and it prints correctly. Even though that object now, it's starting off, again, that description field doesn't have a value. If I tried to move this up here, right, and ran this, I definitely would get an exception, because then I'd be violating that deal I made with Dart when I put the late keyword on there. And I said, hey, trust me on this, I'm going to stick a value in there, right? But this allows me to do some things with non-nullable fields that I wouldn't otherwise be able to do. And that's what the last two examples here are about, the things that this makes possible. So let's take a look at number 12, late circular references. All right. So take a look here. I've got two classes here. Class 1, on lines 1 through 3, I've got a team class that references a coach. And on line 5 through 7, I've got a coach class that references a team. So I've got a circular reference between two objects, such as you might see with some objects coming out of a database. Occasionally, you might have a circular reference, things like that. All right. And then in main, I'm making these two objects. I make a team, I make a coach, and then I assign those circular references, and then I'm done. All right. So take a look at this. Where could you put on this that late keyword to correct these analyzer errors? Take a second and see if you can figure it out. All right, were you able to find a solution? Let me see where I ended up putting mine. There we go. Late final and late final. There we go. And so you'll notice I don't even have to I don't have to take that final modifier off. That's okay. I can have a field that is assigned after object initialization happens, but then once it's assigned, I'm not allowed to set it again, just like any other final value. So this is a thing that's it's actually new to the language with this late keyword. You didn't used to be able to do that, but now I can. So those are initialized after the fact, but once they're initialized, they become read-only. And I can run this and be all done. There you go. All right, we have one more. Late and lazy. So let's take a look at this one. We have compute value up here. So this is a function. All it does is print a little label. It says print in compute value, and it returns a value. That's a very simple computation. Then we have a cached value provider. So you can imagine, say you have a cache that's guarding an expensive function, right? Say compute value was not just returning 3, but it was contemplating the nature of man's role in the universe or something like that. You might only want to contemplate that once and then take the result and store it in a field so that you could send it out multiple times afterwards. And that's what this cache value provider is doing, right? It has a getter for this cached value, and it has a private field that's actually being initialized with this value, right? And so down here in main, there are a lot of print statements in here. So I have calling the constructor, creates that object that says getting value, and then actually prints the value after getting it from the provider. So let me run this, and we'll see what happens. Let's take a look at this. So first up, it goes into main right here on line 11, right? And it says calling constructor. Then it goes out and creates that object, and you can see it immediately calls compute value, right? That's the second thing that's printed down here, in compute value. So it's gone from creating the object on line 13 up to 7, where the compute value is, all the way up to line 1 and started executing that function immediately. And then it's gone to the rest. Then it's printing get a value, and then it prints the value itself. Watch what happens. Actually, what do you think will happen? Since this is an interactive workshop, what do you think is going to happen if I put a late on there? Those 4 statements, how do you think they might be different? Let's find out. I'm going to hit run here. Well, and as you can see, that in compute value just dropped down a step, right? And that's because the late keyword makes this lazy, which is a really interesting nuance. it used to, without late, if I take this out, right? This is an initializer. It's going to get run immediately once that object is created. Dart's going to go, hey, I need a value to put in here. I need it right now, so I'm going to run this function right now and put the value in at initialization time. With late, though, Dart knows it doesn't have to do that, right? I've already told it, hey, I'm going to make sure you don't have to worry about putting a value in here right away, right? I'm going to access it later. There'll be a value in there at that time, right? And so what it does is it also makes it lazy. And so this is a pattern that you can use for delaying expensive computation for initializing an object or something like that, unless you know you're going to need it. You initialize on demand and stuff like that. And it's a neat little thing that's not really null safety related, but has been brought into the language by the null safety syntax. And that's kind of a dorky thing to geek out over, but I just really like that. And so that's our last example for this workshop. It's just that neat little pattern there. Yeah, so that is step 13. We're going to end it here. And so this video, of course, will be on YouTube. We just did this live stream. This video will be on YouTube. You will still be able to access that workshop by the link I showed at the beginning. If you're still with us, I will give you that link again right here in the editor. Flutter.dev/go/null. Dartpad is still bravely trying to automatically complete my string literal. So that's our URL again. We hope you've been enjoying Google I/O 21. We've had some workshops so far. We still have more content coming tomorrow. And you'll be able to find all of it, of course, on our YouTube channel at youtube.com/flutterdev. And so come see us at dart.dev and flutter.dev as well. And yeah, happy coding.